Hello everyone. Let us see solutions for the last part of Polytechnic Lecture Examination ECE 2024 question paper conducted by APPSC. Question 121. Select the option that is true regarding the following two statements. Assertion and reason is given. When feedback is positive, the system will not oscillate until Nyquist criterion is satisfied. The statement assertion is correct. If 1 plus a beta is equal to 1 represents a circle of unit radius with its center at a point minus 1 plus j0 if for any frequency if a beta extends so outside the circle, it is not outside, inside the circle, and feedback is positive because 1 plus a beta it is less than 1, it is inside the circle and it should be less than 1, then reason is, as per this, reason is wrong. So let us see what is feedback, what are the different types of feedbacks. So feedback is a function of the feedback circuit is to transfer the part of output signal to input in proper phase. So the function of feedback circuit is to transfer a part of output signal to input. So there are two types of feedbacks. One is positive feedback and negative feedback. Positive, if the feedback signal is applied as to increase the input signal, that is it is in phase with the input signal, then it is called positive feedback. So negative feedback means if the feedback signal is so applied as to reduce the input voltage, so it is 180 degrees out of phase with the feedback signal is 180 degree out of phase with the input, then it is called negative feedback. So for a positive feedback system, closed loop gain is given as a by 1 minus a beta. For negative feedback system, closed loop gain is given as a by 1 plus a beta. For negative feedback system, closed loop gain less than open loop gain. In negative feedback system, closed loop gain AF greater than A. Closed loop gain is greater than open loop gain. Let us see Nyquist criteria. So feedback is mentioned. Next is Nyquist criteria. Nyquist criteria is a graphical representation or a graphical method for determining the stability of closed loop system. Stability of graphical method for the this is graphical method for determining the stability of closed loop system from its open loop frequency response and closed loop and open loop poles. Nyquist criteria state that number of encirclements about the critical point minus 1 plus j0 should be equal to number of is equal to the poles of open loop transfer function g of s h of s which are in the right half of the s plane. So this is a Nyquist criteria. It can be expressed as n is equal to p minus z. N is equal to p minus z, where p is number of poles of g of s h of s in right half of the s plane. Z is number of zeros of h of s g of s h of s in rh of s plane. Capital N represents number of net encirclements around the point minus 1 plus j0 by g of s h of s plot. So clockwise encirclements are taken as negative and anti-clockwise encirclements are taken as positive. Now, this Nyquist stability criteria states that in a complex plane, if 1 plus a beta represents a circle of unit radius with its center at point minus 1 plus j0, and if a beta lies within the unit circle, if a beta lies within the unit circle and 1 plus a beta less than 1 represents the system is positive feedback system. Even with this positive feedback system will not oscillate until Nyquist criterion is satisfied. So assertion is correct and reason is wrong. So here it should be a beta less inside the circle and 1 plus a beta less than 1. Reason is wrong. Correct option is C. That is 3. Next question. Identify the terminals 1, comma 2, 1, 2, and 3 for a Wien-Bridge oscillator circuit as shown in the figure. So this is a Wien-Bridge oscillator circuit. See the diagram, Wien-Bridge oscillator circuit. So this Wien-Bridge is most commonly audio frequency oscillator is Wien-Bridge oscillator. So in the feedback signal in the circuit is connected to non-inverting input terminal, so that op amp is working as a non-inverting amplifier. Therefore, feedback network need not provide any phase shift. Now the gain of the amplifier from this it is given as 1 plus, so it is say RF or R3. This resistor is R4. 1 plus RF by R4, and the resonant frequency for this circuit is 1 by 2 pi R1 R2. C1, C2. If R1 is equal to R2 and C1 is equal to C2, then resonant frequency is given as 1 by 2 pi RC. Resonant frequency can be written as 1 by 2 pi RC if this R1 is equal to R2 and C1 is equal to C2. And feedback factor beta is equal to 1 by 3. And for sustained oscillations, the magnitude A, this magnitude A should be greater than or equal to 3. From this, RF is equal to 2 times of R4. These are the various possible conditions. Here op amp is used as a non-inverting amplifier. The output voltage from op amp is fed back to both inverting and non-inverting terminals of op amp. This feedback network this feedback network doesn't provide any phase shift. This is a feedback network. This feedback network doesn't provide any phase shift in this RC phase shift in this Wien bridge oscillator. As at resonant frequency, the voltage applied to both inverting and non-inverting terminals are equal and in phase. So this is a plot. Oscillator output gain versus phase. At resonant frequency, this is a resonant frequency. At resonant frequency, the phase shift is 0. At resonant frequency, the circuit reactance equal to its resistance, and the phase difference between input and output is equal to 0 degrees. The magnitude of voltage is maximum at, at resonant frequency. The magnitude of voltage is maximum and it is 1 by 3 1 by third of input voltage. Oh, so here in feedback loop, it consists of series R1 C1 circuit known as high pass filter connected to parallel R2 C2 circuit known as low pass filter. Besides this two RC circuits, this is high pass filter and it is low pass filter. Besides these two, there is two more resistors are there, R3 and R4. Another two arms of Wien bridge consist of two more resistors, R3 and R4. Now the feedback signal is so output voltage. This output voltage is fed back. This is the output voltage and this is a VF represents a feedback signal and V0 represents a output voltage. Now from these diagrams, plus 2 VF is given to plus, that is non-inverting terminal, and V0 is given to 1, that is inverting terminal, and terminal 3 is ground here. The terminal 3 is ground. See the circuit here. So this series parallel arm is connected to ground. Parallel arm is connected to ground. As per question, it is 3, and VF is given to plus and V0. So VF is given to plus and V0. From these two arms of Wien bridge, resistive arms of Wien bridge, it is connected to minus. So that is inverting terminal of op amp. So therefore, option 4 is a correct one. Next question: which of the following wave is generated when a comparator output is passed through an integrator? So generally, so comparator means there are two basic types of comparators. One is inverting comparator and non-inverting comparator. So inverting comparator, non-inverting comparator, depending upon which terminal input signal is applied. So this is a non-inverting terminal, non-inverting comparator. For non-inverting comparator, input signal is given to positive terminal. So that is non-inverting input. Here input signal is applied to positive terminal and negative terminal is given with a reference voltage. If input voltage greater than this reference voltage, output is plus V saturation. If input is less than reference voltage, output is minus low, that is minus V saturation. So similarly for inverting comparator, it is negative. The input signal is applied to inverting input and reference voltage is given to non-inverting input, that is plus input. If input is greater than reference voltage, then output is minus V saturation. If input is less than plus V reference, then output is plus V saturation. So the output of comparator is either high or low. The comparator output is square wave. The output of comparator is a square wave. So once square wave is given to an integrator, it generates triangular wave. Square wave on integration produces triangular wave. So correct option is 2. Next question. And this is related to 555 timer IC and working in unstable mode of operation. So the capacitor C charges to VCC through external resistors. So the statement is correct. In 555 timer IC, working as an unstable mode, the capacitor charges towards towards VCC through external resistors. There is RA and RB resistor, and capacitor voltage rises above the threshold voltage, output goes low. So why output is becoming low means when the voltage across the capacitor exceeds the threshold voltage, the flip flop is triggered so that output is changed. So the statement assertion is correct, and re- reason is the correct explanation for the assertion. So option 1. So let us see the diagram, the functional diagram of 555 timer working in unstable mode of operation. This is a functional diagram of 555 timer working in unstable mode. So from this, unlike in monostable operation, the timer has the timing resistor has now split into two sections, that is RA and RB. So this is RA and RB. The timing resistor is split into two sections, RA and RB. So RA, RB. Pin 7 of the discharging transistor Q1 is connected to the junction RA and RB. So at pin 7, the discharging transistor is connected to the junction of RA and RB. When the power supply VCC is connected, the external timing capacitor C. So this is the external timing capacitor C charges towards the VCC with time constant RA plus RB into C. The time constant is RA plus RB into C. During this time, the output pin 3 is high. So output pin, this is the output pin. During this operation, the output pin 3 is high, equal to VCC, as R is equal to 0 and S is equal to 1. This combination makes the, so R is equal to 0, S is equal to 1. Now the flip flop is set. So for flip flop is set, Q is 1, Q bar will become 0, which has clamped to the timing capacitor. When the capacitor voltage equal to 2 by 3 VCC, the upper comparator triggers. This is upper comparator. When capacitor voltage is equal to 2 by 2 third of VCC, the upper comparator triggers and control flip flop triggers the control flip flop so that Q bar will become 1. This in turn makes the transistor Q1 on and capacitor starts discharging towards the ground through resistor RB and the transistor Q1 with the time constant RB into C. Now the charging time constant is RA plus RB into C and discharging time constant is only RB into C. So this is the operation of 555 timer working in unstable mode. Okay. So when the 555 timer, the applications of 555 timer working in unstable mode are, one is FSK generator and second one is pulse position modulator PPM. Here statement assertion is correct and reason is also correct, and reason is the correct explanation for the assertion. So correct option is 1. Next question. So this question is related to the pin diagram of 555 timer. So pin 2, pin 2 is trigger input. So pin 2 is trigger and pin 3 is threshold. Sorry, pin 3 is output. So that is 4. Pin 5 is control voltage 3 and pin 6 is threshold. So the correct option is A is 1, B is 4, C is 3 and D is 2. Correct option is 2. Pin diagram of IC 555 timer. Next question. Given Smith trigger circuit is given and they asked to calculate the upper threshold voltage. For a Smith trigger circuit, this is a Smith trigger circuit. So input Vi and resistor R3, R1, R2 are feedback resistors which is connected to plus terminal of non-inverting terminal of op amp, and V reference voltage is given. So here there are, it is supplied with VCC, that is plus V saturation and minus V saturation, that is supply voltage plus VCC and minus VCC. Now this is the hysteresis loop. Upper threshold voltage. So the definition of upper threshold voltage is the value of input voltage at which output changes from plus V saturation to minus V saturation. So this is the value of input voltage. This is the value of input voltage at which the output is changing. This is the yellow line. The output is changing. The output is changing from plus V saturation to minus V saturation. So that is upper threshold voltage, and lower threshold voltage is the value of input voltage at which output changes from minus V saturation to plus V saturation. This is lower threshold voltage VUT and VLT. So lower threshold voltage. So the hysteresis with this difference between upper threshold voltage and lower threshold voltage is hysteresis with VH, that is 2R2 into V saturation by R1 plus R2. In the question they have given, calculate the upper threshold voltage with reference voltage 0 and V saturation is VCC, that is 10 volts. So from this, upper threshold voltage is V reference voltage is 0 and V saturation R2 is 5 kilo ohm plus 5 kilo ohm into V saturation 10 volts by R1 plus R2, 5K plus 10K, 50 by 15. So it is 3.33. So upper threshold voltage is 3.33. Correct option is 1. Next question. So this is related to matching of different parameters of half wave rectifier. So for half wave rectifier, what is ripple factor? So ripple, generally the definition of ripple factor is RMS. It is a ratio of RMS value of AC voltage in the wave to average value of the wave. So average value or DC value of the component. So ripple factor is given as square root of IRMS by IDC whole square minus 1. Ripple factor is ratio of RMS value by average value or DC value. Transformer utilization factor is the ratio of DC output power to AC rating of transformer secondary. So it is given as PDC by AC rating of transformer secondary. The AC rating of transformer secondary is nothing but product of voltage and current. And TUF for half wave rectifier is 0.286 RL by RF plus RL. For full wave rectifier 0.81 RL by RF plus RL. RF is a diode resistance in forward bias. RL is a load resistance. And for bridge rectifier there are two diodes, hence we keep 2 RF plus RL. For any winding, AC rating is a product of RMS voltage across the winding to and RMS current flowing through the winding. RMS current flowing through the winding. And next form factor is ratio of RMS value to average value. Peak factor is ratio of peak value to RMS value. See different, and these are diagram for half wave rectifier, full wave rectifier and bridge rectifier. Half wave rectifier there is only one diode. In full wave center tap the bulky transformer is present and two diodes are there. It converts incoming signal to rectified signal. And in bridge rectifier there are four diodes. Full wave rectification is possible in bridge rectifier. So number of diodes in half wave is 1, full wave 2, and bridge it is 4. Efficiency, ripple factor for half wave rectifier is 1.21. Peak inverse voltage is Vm and form factor is 1.57. These are the different values for full wave rectifier, and values for bridge rectifier. Now as per the question, so ripple factor of half wave rectifier is 1.57. Ripple sorry Form factor is 1.57, ripple factor is 1.21. Ripple factor is 1.21. So A is 4. Ripple factor is 1.21. Transformer utilization factor TUF for half wave rectifier is transformer utilization factor. So it is not here. Okay. Transformer utilization factor of half wave rectifier is 0.287 and form factor is 1.57. So form factor is 1.57 and is peak factor it is 1 second. Form factor is 1.57 for half wave rectifier and peak factor is 1.2. So correct option is 4, 1, 5 and 6. So this is 6, 1.2. These are the definitions of ripple factor, transformer utilization factor, form factor and peak factor. So from this tabular column we came to know the values and match the corresponding values to the. This is 6. Next question. It is related to number systems. For a number system, if base or radix of a number system is r, the number of different systems that can be used, number of different digits, number of different digits used in the number system is r. So those digits starts from 0 and ends with r minus 1. Minimum digit is 0 and maximum digit is 0 and maximum digit is r minus 1. Suppose for a number system of 10, so that is base 10, that is base 2, binary number system. For binary number system, so base is 2, the digits are 0 and 1. For octal number system with base 8, the minimum digit is 0 and maximum digit is r minus 1, that is 7. So that is 0, 1, 2 and so on, 6 comma 7. For decimal number system, base is 10, so minimum digit is 0 and maximum digit is r minus 1, that is 9, and the digits are 0, 1, 2, 3 and so on, 7, 8, and the last digit is 9. For hexadecimal number system, for hexadecimal 16, so base is 16, so it starts from 0 and ends with r minus 1, that is 15. 15 is f, so 0, 1, 2, 9, and then 10 is a, 11 is b, c is 12, e and f. These are the different digits in hexadecimal number system. The maximum digit in any number system is r minus 1. So now a is 1, so a consists only ones and zeros, so it related to binary number system. So for option b, the maximum digit is 7, it is related to octal number system. From option 3, 8 is present and b is also present, it is hexadecimal number system. In option d, 9 is present, so it is related, corresponds to binary decimal number system. A1, B2, C4 and D3. Correct option is 1. Next question. Represents a hexadecimal digit for conversion. Conversion of hexadecimal to binary and then from binary to decimal. So from hexadecimal to binary, the conversion is each hexadecimal digit is represented with 4 binary bits. So for E, it is 1110, and for B, 1011. Now hexadecimal to binary is EB, 4401011. So 11101011. So this is base 2. So to convert from hexadecimal to decimal, so EB base 16 is E into 16 power 1, B into 16 power 0. So the value of E is 14, as A is 10, B 11, C 12, D 13, E 14 and F is 15. Now E is 14, 14 into 16 plus B is 11, 11 into 1. So its value is 235. 235 base 10. Correct option is 2. Next question. Every algebraic expression detectable from the postulates of Boolean algebra remains valid if the operators and identity elements are interchanged. So that is a statement. For the statement, conclusions are interchange R and operators, replace 1 by 0 and 0 by 1. Both conclusions are true for the statement. So it represents a duality theorem. So duality theorem of Boolean algebra states that every algebraic expression remains valid if the operators and identity elements are interchanged. So duality principle states that every algebraic expression detectable from the postulates of Boolean algebra remains valid if the operators and identity elements are interchanged. So this is related to duality theorem and both conclusions are true for the given statement. Correct option is 3. Next question. So we need to simplify the given expression. Y is equal to a plus a bar b plus a bar b bar c plus a bar b bar c bar and d. These are the different laws that we are using in Boolean algebra. One is distributive law. P plus x pi can be written as p plus x plus p into p plus y. X plus x bar is 1. 1 plus x is 1. That is identity law over OR gate. So using these three laws, we will try to simplify this expression. So that is a plus a bar b. So a plus a bar b can be written as a plus a bar into a plus b plus a plus b bar. We will take common here. A plus b bar is common, so from this it will become c plus c bar d. So expand this, c plus c bar d, that is a bar b bar c plus c bar into c plus d bar. So now a plus a bar is 1, a plus b. So x plus x bar is 1. So it can be written as 1 into a plus b plus c bar is 1, a bar b bar c bar plus d bar. Now again, so this is x, c plus d is y. So that is b plus a. Rewrite this expression. So that is b plus a plus a bar b bar c plus d. Here it is c plus c bar into c plus d. Now this is p x y. Again apply this distributive law. So this is p plus xy. Apply distributive law here. So from this we will get b plus a bar b a plus c plus d. So again apply distributive law here. A plus a bar b, a plus a bar into a plus b bar. So it will become b plus a bar a plus b bar a plus c plus d. A plus a bar is 1. So b plus a bar plus b bar plus a plus c plus d. Now this is x and this is p plus xy. This is p, this is x and this is y. Again apply distributive law so that we will get b plus a plus b bar into b plus a plus c plus d. Again b plus b bar is b plus b bar is 1. So 1 plus a into a plus b plus c plus d. So 1 plus something variable is its value is 1. So final is a plus b plus c plus into d. So the correct option is a b c d. The given expression is reduced to a b c d. So option 3 is correct. Next question. So given function f of w x y z is equal to 0 1 2 4 6 8 9 12 13 and 14. These are the min terms given. So we need to simplify the expression using k map. So simplify the expression using corner map. So using k map, 4 variables are there, 16 cell k map, and the variables are w x y z and the question they have given. So place the min terms in the corresponding elements of the k map and then go for the mapping of cells. So there are one octet is possible. For this octet, the corresponding term is y bar, and there are two quads. So green line represents one quad. Mapping of these two ones and mapping of these two ones. A quad is formed. Min terms. A quad is formed. Similarly, these two ones and these two ones. Another quad is formed. For these two quads, The corresponding minimal terms are w bar, z bar, and x bar, z bar. So the final expression is y bar plus w bar, z bar plus x, z bar. So this is the final expression for the given function. Minimal expression for the given function. So grouping of cells, a grouping of two cells, grouping of four cells will form a quad, and quad eliminates two variables. Eight cells is octet. Grouping of eight cells form an octet. An octet will eliminate three variables. Similarly, grouping of two cells, that is binary, it eliminates one variable. So number of variables it can eliminate is 1, 2, 3. Here it is a quad, it eliminates three variables. For the four variable function, it eliminates three variables. So similarly, for this is an octet. Octet eliminates three variables. Similarly, for quad, it eliminates two variables. The total number of cells in K-map is 2 power n, where n is the number of variables. Here there are four variables. The total number of cells in K-map is 2 power n. Total cells in K-map. Next question. A multiplexer. There are 2 power n input lines and n selection lines whose bit combinations determines which input is selected. Statement is correct. So multiplexer acts like electronic switch that selects one of the 2 power n sources. It is also correct. So we know that multiplexer is a combinational logic circuit. So multiplexer is combinational logic circuit. This is multiplexer with 2 power n 2 power n inputs, n selection lines and one output. 2 power n inputs, n outputs and one output. So multiplexer is a combinational circuit with 2 power n input lines, single output line and n selection lines, and the selection of particular output line is decided by the bit combinations present on the selected lines. So multiplexer is also called many to one switch or many to one switch or parallel to serial converter, analog selector switch or data routing switch or analog selector switch. Both assertion is correct and reason is also correct, and reason is a correct explanation for the assertion. So correct option is A. Next question. So decoder and demultiplexer operations are obtained from the same circuit. De- uh, A is assertion and reason is decoder with enable input is referred to as demultiplexer. So both statements are correct. Because encoder with enable input is multiplexer and decoder with enable input is demultiplexer. So first, what is decoder means? Decoder is an multiple input, multiple output logic circuit. So decoder we can write here. Decoder is an multiple input, multiple output logic circuit. So many data inputs, that is many inputs, many outputs, multiple input, multiple output logic circuits, which converts coded inputs to coded outputs, where input and output codes are different. If suppose this is binary decoder, it has 2 power n inputs, 2 power n inputs, n outputs, and one selection line, enable line. Selection or enable line is present. Next, for a demultiplexer, there is single input, 2 power n outputs, and n selection lines. So this is demultiplexer. Now this decoder with enable input is functioning as a demultiplexer. The statement is correct. So input and output codes are different in decoder. The input code has generally fewer bits than output code. So this is n inputs, 2 power n outputs. Decoder is an multiple input, multiple output logic circuit which converts coded inputs to coded outputs where input and output codes are different. Suppose for a binary decoder, there are n inputs and 2 power n outputs with one enable line. So similarly, demultiplexer is having single input line, 2 power n output lines, and n selection lines. Now the 2 by 4 decoder may act like 1 by 4 demultiplexer and vice versa. Usually, this decoder is provided with enable input line to activate the to active decoded output based on data inputs. To activate the decoded output based on data inputs, when any one enable input is unasserted, all the outputs of decoder are disabled. Okay. Now the statement assertion and reason are correct, and reason is a correct explanation for the assertion. So decoder with enable input will act like a demultiplexer, and encoder with enable input acts like a multiplexer. Example is 2 by 4 decoder may act like 1 by 4 multiplexer. For decoder and demultiplexer, the number of output lines are 2 power n. For demultiplexer, input lines is 1 and selection lines are n. For decoder, input lines are n and output lines are 2 power n, and enable input is present. So this is enable input. Next question. It is related to multiplexer. Multiplexer or data selector logic circuit. It is a combination logic circuit that accepts several data inputs and allows only one of them at a time to go through the output. The routing of desired data input to output is controlled by selection lines. In the output it is y2, suppose s1, s0, and the output y. Which input line is selected to route it to output. For selection lines 0 0, output is i0. For it is 0 1, output is i1. For 1 0, s1 is 1 and s2 is 0, the output is i2. For both are 1, output is i3. Corresponding input line i3 is connected to output. If s0 is 1, s1 is 1. Similarly, if s0 is 1 and s1 is 1 and s0 is 0, the i2 line is connected to output. The data or information on the i2 line is routed to output. So correct option is 2. If s0 is 1 and s0 is 0 and s1 is 1, output y is i2. Next question. For this given logic circuit, we need to calculate the output. So a b are the inputs and output is y. So let us see at this point say it is x. The output of this gate 1 is x and output of gate 2 is y. Let us assume this is gate 3, or we can write as p q. Now p value is p is a bar b bar. Gate 1 is NAND gate a bar b bar with bubbled inputs. So here it is bubbled inputs, NAND gate with bubbled inputs a bar b bar whole bar, and q is bubbled input OR gate, that is a bar plus b bar. So input to the gate 3 bubbled inputs are there, that is p bar q bar. So from this p bar is a bar b bar whole bar, that is a bar b bar, and q bar is a bar b bar whole bar. So these p bar and q bar inputs are connected to gate 3, so that is NOR gate, P bar plus Q bar whole bar. This is output Y. P plus Q. Using De Morgan's law, P bar X plus A plus B whole bar is A bar dot B bar. This is De Morgan's law. So similarly apply De Morgan's law, it will become P Q. So we know that P is A bar B whole bar and Q is A bar plus B bar. So from this again apply De Morgan's law, A bar whole bar plus B bar whole bar, A bar plus B bar. So that is A plus B, A bar plus B bar. Now it will become A bar, A bar, A B bar, B A bar, B B bar. So A bar is 0, B B bar is also 0, A B bar, B A bar. So that is A XOR B. So this whole gate works as an XOR gate. The whole gate given in the circuit work as an XOR gate. Next question. A decoder is a combination logic circuit that converts binary information from n input lines to maximum of 2 power n unique output lines. So the statement is correct. So decoder is a combination logic circuit with 2 power n binary input lines and n input lines and 2 power n output lines, such that only one output is activated for each one of the possible combinations of input. One output is activated for each possible combinations of input. Among the 2 power n input lines, only one output line will be high for each input code. In decoder, depending upon the binary data applied, one of the output line will be logic 1. So the purpose is to generate 2 power n minterms for n input variables. So statement conclusion 1 is correct, and each combination of input will assert unique output. So statement 2 is also conclusion 2 is also correct for the statement. So correct option is 3. There are 2 power n output lines for n corresponding input lines. There are 2 power n output lines. Among the 2 power n output lines, only one line is high. So the selection of that particular line is decided by the data bits on the input lines. Next is related to PLA. So in implementing a combination logic circuit with PLA, careful investigation must be undertaken in order to reduce the number of distinct product terms. So it is correct. Assertion is correct. In a PLA has finite number of AND gates only. The statement is wrong. PLA, both AND gate and OR gate are programmable. Any Boolean function in SOP form can be implemented using PLA. So therefore assertion is correct and reason is wrong. Correct option is 3. Next question. It is related to SR latch. For both are 0 0, no change of state in SR latch. If 0 1, output is Q is reset. For 1 0, output Q is set to 1 if both S is 1 and R is 1. If both S is 1 and R is 1, in this case it is an intermediate state or prohibited state. So it is assertion is statement is correct. Conclusion 1. In SR, latch is a latch with two cross coupled NOR gates and two inputs labeled S for set and R for reset. Conclusion 1 is correct. Intermediate condition makes the circuit easier to manage. So conclusion 2 is difficult because when both S and R are logic, S input and R input are at logic 1, then the outputs of both NOR gates are low. So the output of both NOR gates are low means the fundamental design of latch, that is output should be complementary. The fundamental principle in the design of latch or flip flop is the output should be complement to each other. This condition is intermediate condition or prohibited state. It is an unpredictable, which is unpredictable. So the conclusion 2 is false, only conclusion 1 follows. Next question. In SISO, serial input serial output mode of 4-bit shift registers, There are 4 flip-flops with inputs D0, D1, D2 and D3 and 4 outputs Q0, Q1, Q2 and Q3 respectively, and D0 is Q3 bar, D1 is Q0, D2 is Q1 and D3 is Q2. What will happen to the output after 7 clock pulses? Indirectly in the question he has given Johnson counter or twisted ring counter or a switch tail ring counter. So that is D3, it is given to D0, that is DA. So let us analyze the circuit for 7 clock pulses. For first clock pulse, all are 0. For initially, all the data stored in the flip flops are 0 for first clock pulse. So D naught it will become 1. So it will become DA will become 1. So that is 1 0 0. Similarly for second clock pulse, so 0 will become 1, double 1 double 0. For third clock pulse, it is triple 1 0. Fourth clock pulse, all ones. Now fifth clock pulse, so this one will become 0 here. For sixth clock pulse, and for seventh clock pulse it is 0 0 0 1. For seventh clock pulse the output is 0 0 1 from this Johnson counter or switch tail ring counter of 4 digits. Next question, identify the following circuit. So in this circuit they have mentioned this flip flop 4 is having MSB bit and flip flop 1 is LSB bit, and it is an asynchronous counter. It's a non-binary counter because there is no common input. There is no common clock signal. The output of first signal is given as clock to the second signal. Output of second is given as third clock input to the clock, and output of third flip flop is given as clock input to the fourth flip flop. Hence, it is an asynchronous circuit. We need to decide whether it is an up counter or down counter. It is a non-binary counter or a mod counter. It is a non-binary counter or mod counter, and its nature is asynchronous. Next is we need to find the mod number, and as well as it is either up counter or down counter. Here there are clear input, flip flop input is clear input, and the gate is NAND gate. So clear input and NAND gate, the inputs to NAND gate are Q output. Inputs to NAND gate are Q output. So from this clear asynchronous input Q and NAND gate, so it refers to up counter. So it is an up counter. Next we need to find the number of states counted by this up counter. Here flip flop 1 output is not connected to the gate, flip flop 2 output is connected to the gate, flip flop 3 output is not connected 0, and flip flop 4 output is connected to the input to this gate. So that is 1 0 1 0. Therefore the given circuit is, first of all, it is an asynchronous counter because clock signal is not common to all the flip flops. Next is asynchronous counters or mod counters or non-binary counters. Next is we need to find the mod number. So based on the data based on the outputs, flip flop outputs connected to this clock signal. So therefore it is mod 10 counter 1010, it is mod 10 counter because they have given MSB and LSB. Next, whether it is an up counter or down counter, based on this column we can, based on this four criteria we can decide whether it is up counter or non counter. Here clear input is connected to NAND gate, and the inputs to NAND gates are Q output. Positive output of flip flop is connected to inputs to the NAND gate with clear direct input. So hence it is an up counter. Therefore given circuit is mod 10 asynchronous up counter 4 bit, because 4 bit means 4 flip flops are there and total states are mod 10 asynchronous up counter. Next, acquisition. Next is uh, question related to sample and hold circuit. 4 different times are given: acquisition time, aperture time, conversion time, sample and hold time. So all these times are related to the sample and hold circuit. What is acquisition time or secure time? So the time required for the change in holding capacitor to raise its value up to a level that is close to the input voltage during the sampling is called acquisition time. Acquisition time is also called securing time. So the statement is related to acquisition time. The time required for electronic switch to close and hold the capacitor to charge in a sample and hold circuit is acquisition time, or the time required for the charge in the holding capacitor to rise up to a level that is close to the input voltage during sampling is acquisition time. So acquisition time is a time it takes for the capacitor to charge up to a level close to the input voltage. Next is aperture time. Let us see the aperture time is, it is also known as opening time. It is a time delay between the initiation of output voltage tracking the input voltage and the initiation of hold command, or the time taken by the capacitor to switch its position from sampling to holding is aperture time. The time it takes for the capacitor to switch from sampling to holding. So other name for this aperture time is opening time. So this is aperture time, acquisition time, aperture jitter. It is given in the graph. Next is conversion time. So that is sampling time and hold time. So sampling time is the time during which sample and hold circuits generates the sample of input signal is sampling time. Hold time is the time duration of the circuit during which it holds the sample value is called holding time. Okay. Correct option is 1. So from this, the time required for the electronic switch to close and hold the capacitor to charge in a sample and in a whole circuit is acquisition time. Acquisition time is also called secure time. Next question is related to weighted resistor digital to analog converter. In weighted resistor DAC, this is a diagram of digital to analog converter weighted resistor DAC. Each input resistor has different weights, and the weight for the MSB resistor is MSB resistance is or MSB digit the digit M- the weight for the MSB digit resistance is 2 power 1 into R, and for LSB resistance is 2 power n into R. So the resistance values are in weight according with the digit binary weight. Binary weight. So here simply op amp is working as current to voltage converter. So the statement is weighted resistor digital to analog converter takes the digital data as input and converts into analog voltage or current proportional to the weighted sum of digital inputs. So this statement is correct. The conclusions related to the statement are, it is a simple resistor divider network. Conclusion 1 is true. It is a simple resistor divider network. Oh. Next, each resistor in a network has different value. So each resistor is having different values. 2 power 1 into R, 2 square, 2 cube into R, 2 power n into R. So different weights are given for each resistors. So this is LSB d power n and MSB is d power 1. D1 bit is given for MSB and Dn bit is given, nth bit is given for LSB. So both conclusions are true for the given statement. So correct option is 3. Next question. It is related to memories. So which of the following memories is used to store the bootstrap program in computer? So generally this cache memory and random access memories are non-volatile memories. So if non-volatile memories means when the data is completely erased once the system is shut down. Once the power is off, the data is completely erased. Bootstrap loader is a program that starts up the operating system when the computer is turned on. So bootstrap loader should be stored in the volatile memories. So bootstrap loader is a program stored in computer read-only memory or EPROM. So computer read-only memory or EPROM. It doesn't store in hard disk. These two are non-volatile memories, but it doesn't store in hard disk. It is stored in ROM. Next question. It is related to dynamic RAM. So RAM is categorized into two types. One is dynamic RAM and static RAM. So in dynamic RAM, data is stored in flip flops, so mass capacitor. In static RAM, data is stored in flip flop. So these SRAMs are faster and used in cache memories. DRAMs are slower and used in main memories. The power dissipation in SRAM is quite high when compared to DRAM. Next, density for SRAM is low and density for DRAM is high. Periodic refreshment is required here because we are using a capacitor, hence periodic refreshment is required. So no such refreshments are not required in SRAM. In the question they have given, in a dynamic RAM, capacitors are periodically recharged by refreshing the dynamic memory. The statement is correct. So DRAM consists of internal latches that stores the binary information. Internal latches is present in SRAM. Rather in DRAM, it stores the data in capacitor rather than a latch. So DRAM is nothing but MOSFET plus capacitor. The capacitor cannot hold its charge over an extended period of time and will lose the stored data unless its charge is refreshed periodically. So correct option is A is true and R is false. Next question. Which of the following statement is false regarding the DRAM? So DRAM means periodic refreshment is required. As seen in previous question, the capacitor cannot hold its charge over an extended period of time and it will lose the stored data bit unless its charge is refreshed periodically. So periodic refreshment is required, no leakage of charge stored. Next question. Which of the following instructions of 8085 microprocessor add content of register BC and HL pair and the result is stored in HL? So this add R. So R may be A register, accumulator, or B, C, D, E, H, and L, M. So add R. This command adds the content of register to accumulator and stores the result in the accumulator. Add M, add B, add M, add memory, add B. These two instructions add the content of register to accumulator and stores the result in the accumulator. Whereas DADB, this is an instruction that adds the content of BC register pair to the HL register pair and stores the result in HL register pair. So the correct option is DADB. Next question. Related to instructions of 8085 microprocessor, 8085 microprocessor LDA. So LDA is load the accumulator with the contents of memory locations, that is copies data from memory location to accumulator. The content of memory location is not altered. MVI is move immediate, copies immediate data to register. MOV is move data between the registers, memory and output ports. Now this MVI is an opcode with operands m comma with m comma 8-bit data. It is of 2-byte instruction. So MVI is 2-byte instruction. So B is 2. Next LDA. So LDA 16-bit address. 16-bit address. It is 3-byte instruction. MOV is move M comma R. It is 1-byte instructions. So correct option is 3. Next question. In the 8085 microprocessor instructions, different types of instructions are there. That is logical instructions in 8085, arithmetic instructions in 8085. Different arithmetic instructions are add, add, adi, adc, aci, sub, sui, ssb, sbi, inr, inx, increment register, inx, dcr, dcx, dad. These are the different arithmetic instructions in 8085. Similarly, logical instructions are logical and, logical or, logical xr, that is xra, cpl, logical complement, cma, complement accumulator. Next is data transfer instructions and branching instructions. These are the 4 different varieties of instructions in 8085: data transfer, logical instructions, branching instructions, and arithmetic instructions. From these instructions, they have given jump, JMP, jump unconditionally. JMP, jump unconditionally. It is an it comes under branching instructions. Branch operation. So branch operation is JMP. So B is 3. Next is data transfer instructions. So data transfer instruction, it is STA. So data transfer instructions, it comes under STAX. So data transfer instruction. So that is A is 2. Similarly DCR, decrement register. So decrement register is arithmetic operation. Next is CMA, complement accumulator. It comes under logical instructions. So correct option is 2. Correct option is 2. Next question. 8085 microprocessor. Which of the following operations is performed when signal IO by M bar, S1 and S0 are 0, 1, 1 and RD bar, W bar are 0, 1 respectively. So given. So 0, 1, 1 it is given and 0, 1 is given. So here it is, mission cycle is opcode fetch. Opcode fetch is a mission cycle. For memory read, it is 0, 1, 0 and 0, 1. So this is for memory read, and memory write it is 0, 0, 1, 1, 0. This is for memory write. And for, so these are the different machine cycles, but as per the question 0, 1, 1 and 0, 1, the correct option is opcode fetch, that is 3.